So, comparison of numbers written in scientific notation and interpreting scientific notation using technology. All we're doing is comparing numbers either greater than or less than. That's all we're doing today. This is a whole lot of salada with words that's going to make it easy for you to understand, except it doesn't, because it's a lot of words that don't make a lot of sense. Guess where the words are going to come from? This guy, who has funny looking hair and has 2 thumbs. So, let's take a look at exercise 1. Here's what you have to understand. The key to today are 2 things. The whole numbers and the magnitude. Okay? Whole numbers and the magnitude. The magnitude is that exponent. So, the Fornax dwarf galaxy is 4 6/10 times 10 to the 5th light years away from Earth, while Andromeda 1 is 2.430 and 430 thousandths times 10 to the 6th light years away, which is closer to Earth. So, we want the smaller number, because it needs to be closer, which needs to be less. So if we want which one's closer to Earth, we're looking for the smaller number. The first thing that we look at to see comparisons is, are the exponents the same? In this case, the exponents are absolutely not the same. The next thing we need to know is, are they both written in scientific notation? Yes, they are. Because if they're not both written in scientific notation, you want to get them written in scientific notation. So we're here. They're both written in scientific notation, but they do not have the same exponents. So now I look and I say, okay, we want the one smaller. Look for the smaller magnitude. Which is smaller, 5 or 6? Well, in this case, 5 is smaller, so which is closer to Earth? Fornax dwarf galaxy is closer because the magnitude of 5 is less than 6. Okay? This isn't tough. Okay. Moving on. Exercise 2. The average lifetime of the tau lepton is 2 and 906 thousandths times 10 to the negative 13 seconds. And the average lifetime of the neutral pion is 8 and 4/10 times 10 to the negative 17 seconds. Explain which subatomic particle has a longer average lifetime. So now if it's longer, we're looking for the bigger number. 2 things that we're looking for are whole numbers, the magnitude. Once I've done that, I look and say, okay, do they have the same exponents? No, they do not. Then I ask myself, are they written in scientific notation? Yes, they are. Between 1 and 10, we're good. We're looking for the bigger number. So remember, when we talk about negatives, the bigger the negative means the smaller the number. So because they have different exponents, which exponent is bigger? Is negative 17 bigger or is negative 13 bigger? And if you have trouble with this, think about your number line. Here's 0, here's 100 away over there. Where's going to be negative 13? Well, negative 13 is somewhere down here. Where does negative 17 go? Is negative 17 closer to 100 or is it farther away? Well, it's farther away. So which number is closer, which is bigger than negative 13? So tau lepton has a longer average lifetime. Plain and simple. That's it. Okay? Now, does it get a little bit trickier than this? Absolutely. Skipping this one, going to this one. Okay, comparing. So when we compare, we're looking for a greater than or less than. So really I want to say 9 and 3/10, and I want to have a bottom. help if I wrote this correctly. 9 3/10 times 10 to the 28 is what? Greater than, less than, or equal to 9 287, 9 times 10 to the 28th. Okay, so they're both written in scientific notation. First numbers are 9, exponents are the same. Okay, so now that doesn't help me. When we have the same numbers as our whole digit and our exponents are the same, forget about the exponents. Forget about that base 10. Rewrite your number as 9.3, 9.2879. And then think about it as money. Which would you rather have? And if the second digit's different, erase the rest. Would you rather have $9.30 or $9.20? Which is bigger? Well, $9.30 is bigger, which means 9 3/10 is bigger than 9 2/10. I can only do this because my exponents are exactly the same. So I would write 9 3/10 is greater than that 9 2/10. Moving on. It says, Chris said that 5 3/10 times 10 to the 41st is less than 5 301 thousandths times 10 to the 41st because 5.3 has fewer digits. Even though he's right, 5 3/10 is less than this, it's not because it has fewer digits. Show him an example to illustrate that his reasoning would result in an incorrect answer and explain. So first off, 5 3/10 is less than 5 301 because really this is 5 300 okay? Or 300,000, 301,000. Which is bigger, 300 or 301? Well, the 301. But let's do something that has more digits that would make it wrong. Let's go 5 3/10 times 10 to the 41st and say that that's going to be greater than 5 2/10, 176 times 10 to the 41st. Even though this has more digits, it's still going to be less than this because if I made this the same number of zeros, so it goes out 1, 2, 3, I'm dropping the exponents because they're the same. Which is bigger, 5.3 or 5.2? Well, this guy. So it doesn't matter how many digits it has, it just matters which truly has the greater next digit. So 5.3, 5.3, 5.30, 5.30, 5.300, 5.301. One's bigger, which is why this number is bigger than this digit. We have a test. Tomorrow you will be reviewing and then we have a test. Tomorrow or Monday or whenever the next day of class is, we will be reviewing. And then we will have a test. So, your homework from the problem set is number 2 and number 3. There are no extension questions today. You are doing numbers 2, you are doing numbers 3. And that takes us through module 1. Bam.